Hi everybody, Mr. Gerhard here in the beautiful hotel room in Massachusetts while on the way at the AP conference. I was hoping that you would take a minute or two and watch this video, kind of review some of the things that you've learned before about lines on section 1.10, and then tomorrow you'll be able to do some of the work that I'm asking you to do in class. So I hope this helps, and I hope you learn something and it refreshes some memories that you may have had from Algebra 2 or even Algebra 1, because this is some pretty easy stuff. So first things first, lines that we talk about all have a slope. That's the number one thing that they have, and that's the most important thing for a line. You remember slope is denoted by the letter M. It's rise over run, and you can also use y2 minus y1 over x2 minus x1. Sometimes you learn delta y over delta x as your change in y over change in x. That's how you figure out the slope. If you have 2 points, make sure that you label them like x1, y1, and x2, y2. That way you can go ahead and make sure you plug them right back in, just like if you're working at McDonald's, you'll need to follow a line for the Burger King or for the Big Mac. All right. Two characteristics of lines that we need to make sure that we know are parallel lines have the same slope. So if two lines have the same slope of, say, 2, or if lines have a slope of 1/2 and 1/2, then they're parallel, meaning they're never going to run into each other. If lines are perpendicular, then that means that the slopes have negative reciprocals. And for example, that would be like -1/2 and +2. If you had a line that had a slope of -1/2, and a slope of 2, another line, they would be perpendicular, meaning they meet at a right angle. Another example would be like if you had one at -3/4 and +4/3. That would mean those lines would be perpendicular because they're opposite reciprocals or negative reciprocals. In terms of how we label lines, we can use point-slope form, which is helpful if you have a point and the slope, hence point-slope form. Slope-intercept form if you have the slope and the y-intercept. And general form is a little bit trickier, but that's helpful if you have the x and y intercepts. If you have the x and y intercepts, you can kind of plug those in. Any line that's x equals a number, such as x equals 2, is a vertical line going through 2 on the x-axis. Here, a horizontal line, y equals a number, say y equals 2, would be a horizontal line on the going through the y-axis. So x equals 2 would be right here. I'll draw it in blue. Vertical line going through 2 on the x-axis, and y equals 2 would be here on the y-axis going horizontally like that, except that's not horizontally. So parallel to the x-axis, that would be y equals 2. All right. Type of problems that we're going to have are things like this, where I'm going to give you some information, you have to identify what the line is. Some are very easy, such as here we have slope of 2 and y-intercept of -5. Well, if I have a slope and a y-intercept, I'm probably going to use y equals mx plus b, because that's slope-intercept form. Slope-intercept, real creative, right? Here in this case, m is equal to 2. And the y-intercept is -5. And so I know y equals 2, b equals -5. It doesn't hurt to underline or write that out. And then we're just going to write it in terms of y equals 2x minus 5. And that's our equation of the line. If you wanted to write it in some other form, you could and adjust it this way, but that would be perfectly fine with that. For this second example, it gives me a slope of -1/2 and a point of 2, -3. Now I'm going to go ahead and label this point as x1, y1, and I'm going to say that my slope is -1/2. Now, point slope, I think that rings a bell. Oh yeah, point slope form. So what I'm going to do is I'll rewrite point slope form. It's y minus y1 equals m times x, minus x1. Now this can be confusing for some of you because you want to put -3 where the y is, or 2 where the x is. But what I'm going to do is that's why I labeled them, is say y minus -3 equals -1/2 x minus 2. Now this is in point slope form, but we need to simplify a little bit. So we're going to say y plus 3 because minus a -3 is positive. And I'm going to distribute this -1/2. So -1/2 times x is -1/2 x. -1/2 times 2, -2 is a positive 1. Now to make this like this, where we have form of slope-intercept, I'm going to subtract 3 from both sides. And I get y equals -1/2 x minus 2. And that's my equation of the line. All right. It's going to get a little trickier, such as this here, where they say find the line that goes through the points 4, 3, and -1, 5. And so right before I get going, I'm going to label it x1, y1, oops, and then x2, y2. And in doing that, what I'm going to do is say, well, do we have a 2-point formula? Well, I'm going to go back over here. We got point slope, we got slope intercept, and we got general. We don't have a point-point form. So what I need to do is I need to use these 2 points to come up with a slope. And so I'm going to say m equals y2 minus y1 over x2 minus x1. And then I plug in what I know. So y2 is 5, y1 is 3, x2 is -1, and x1 is 4. So 5 minus 3 is 2, -1 minus 4 is -5, so -2/5 is my slope. That's m. Well, now I have a point and a slope, and so what I can do is use those in point slope form. Y minus y1 equals m times x minus x1. Well, y minus, let's use y1 right there, 3, equals -2/5 for m, x minus x1, which is 4. Let's distribute the -2/5. That's y minus 3 equals -2/5 x plus 2/5 times 4 is 8/5. Add 3 to both sides. I'm going to bring that up over here. I'm going to get y equals -2/5 x plus, let's see, 3, that would be 15/5. 15 and 8 is 23, so 23/5. It's kind of an odd number, but we'll work with it anyways. And what that means is that the slope is -2/5, the y-intercept is 23/5, and that's our equation. And in our final problem here, it says find the line that goes through the point 1, -3, and is perpendicular to the line y equals 2x plus 4. Well, for 1, -3, I'm going to go ahead and label that x1, y1. And we don't have a point in the equation formula, but this is perpendicular. And so the slope of the line that they gave us is 2. And so the slope of the line that's perpendicular, this little upside down t means perpendicular, is going to be -1/2. I remember that because I said it 10 minutes ago, saying that opposite reciprocals or negative reciprocals mean parallel lines, or perpendicular lines, sorry. So now I have this slope and this point slope form. Comes in handy once again. Y minus y1 equals m, x minus x1. And so then I put in what I have, y minus -3 equals -1/2 x minus 1. Distribute, make it nice, y plus 3 equals -1/2 x plus 1/2. Subtract the 3 from both sides, subtract the 3, and I get y equals negative 1/2 x. 1/2 minus 3 is going to be negative 2.5 or negative 5/2. And that's our equation. So essentially, I hope this helped in doing some of those problems. You can refer back to it tomorrow in class if you need help while you're doing the worksheet that I left for you. And yeah, I hope you learned something. So we'll see you Wednesday, and we'll get everything straightened out then. Talk to you later.